Hey everyone, so today we are going to use what we learned or reviewed in the last class to actually graph. So we're graphing in all forms. So pause and try the do now, another SAT question. So which of the following is not a solution of the inequality? So to solve an inequality, we get all the x's on one side. You're basically going to treat it like it's a regular equation. So I'm going to, minus 3x. Wow, I should definitely not be using that. Whoopsies. All right, there we go. Minus 3x. So negative 5, x minus 3. And then add 3 to both sides. Now, I purposefully did not say what that symbol is. So think about what that symbol means. So now, which is not in the solution? So is it true, negative 2, that symbol, negative 1? Is that true? Is negative 2 greater than or equal to negative 1? It is not. So that one's actually the answer. So remember, if we were to graph this, negative 2, closed circle. Now remember, you have to read from the x. It's not greater than, even though it's, a lot of students say, oh, it's pointing to the right, it's that way. In this case, the x is on the wrong side, so it's actually that way. So negative 1's over here, negative 3 is here, negative 5 is over here. So everything is in this shaded region except for negative 1. Now what you can do if you forgot how to solve, you could have just plugged in, right? If I plug in, right, 3 times negative 1 minus 5 is greater than or equal to 4 times negative 1 minus 3. And you can just check, is that true? You end up with negative 8 is greater than 1. Is negative 8 bigger than 1? No. So A is not in the solution. Okay, so again, in the last class, we talked about finding the vertex, roots, and y-intercept of a parabola. So I want you to do all of that with that equation. Again, look back at your notes, number 32. This is standard form, right? How do you find the vertex in standard form? So negative b over 2a. So that's negative 12 over 2 times 3. 12 over 6 is 2. And then we plug in 3 times 2 squared, 12 times 2 plus 9. What do we get there? I got negative 3. Roots, we set our equation equal to 0 and we solve. So I'm going to do b down here. 3x squared minus 12x plus 9 equals 0. How do we solve that? So you could do quadratic formula, but if you notice, you can divide everything by 3. We have a GCF. So x squared minus 4x plus 3 equals 0. That's an MC chart. We're multiplying to 3, combining to negative 4. 1 times 3. So x minus 1, x minus 3 equals 0. So that means x equals 1. So we have 1, 0. And x equals 3, 3, 0. X minus 1 equals 0. X minus 3 equals 0. And then the y-intercept, plug in 0. And what do we get? 9. And then if you remember the symmetric point, we double the vertex. So 2 doubled is 4. And then we use our c value. So let's plot 2, negative 3, 1, 3, 9, 4, 9. And there's my nice skinny parabola. All right, so that is standard form. All right, so now we're going to do, vectored form. So again, pause the video and look back at your notes from 32. What do you do when it's factored? So even though it says vertex first, we're going to find the roots first. So x plus 9 equals 0, x minus 5 equals 0. I get x equals negative 9, subtract 9 on both sides, add 5 on both sides, so those are my roots. The reason we do that is to find the vertex, we find the average. So negative 9 plus 5 divided by 2. Negative 4 over 2 is negative 2. So my vertex is -2, comma. To find the y, we plug in. So -2 plus 9, -2 minus 5, and we get -49. Y-intercept, we plug in 0. 0 plus 9, 0 minus 5 is -45. So 0, -45. And then symmetric point, double your vertex, -4. The y value is -45. All right, so now we're going to graph that. I'm going to label my graph. Notice these numbers are kind of big, and that's why I gave you just the axes without lines on them. So I have to go down to -45. I have to go over to -9, 5. I need a -4. -4 would be like there. All right, so I've got my roots are 5, -9, oops, -2, I forgot -2, 49. -2, 49 is going to be there. I got that point and that point. Not so pretty, but that's okay. So that is when it's factored, right? Start with the roots, find your vertex. And then finally in vertex form. So this is the one that's really easy to find the vertex. How do we find the vertex of that? Change the sign of the inside, outside stays the same. For this one, it's the roots that are really hard to find. Looking at the graph, if you have the graph, it's easy, but to find the roots, we have to set the equation equal to 0. All right, so now we're going to solve for x. What do we do first? I'm going to subtract 8 on both sides, so -8. And then I have to get the parentheses by itself, so I'm going to divide by 2, -2. So 4 equals x plus 5 squared. Now that that's by itself, the parentheses is by itself, even though there's stuff inside, we can get rid of the exponent of 2. Opposite of a square is a square root. So x plus 5 equals plus or minus 2. Don't forget your plus or minus. And then we subtract 5 on both sides. Don't leave it like that. What's -5 plus 2? -5 plus 2 is -3. And then -5 minus 2, -7. Y-intercept, again, our x is 0. Just plug in 0. -2, 0 plus 5 squared plus 8. I highly recommend you use a calculator because we get -42. Symmetric point, -10, -42. So I did give you a regular graph, even though the y-intercept doesn't fit. We're going to plot everything else. So -5, 8 is right there. We've got -3, -7. So this is also one where we could use our shifting rule, since it is a vertex form. Over 1, down 2, over 1, down 2. And there's my parabola. And that's it. That's the 3 different methods. All right, so this is just review. Use these examples to help you with the homework and keeping track of which function is which. All right, so we have a worksheet, and then I'm also going to give you some IXL to do. All right, have a great day.